Calculus lesson on summary of curve sketching. So this is a warm-up. This is something that you should work on and we'll go over in class, but it should be completed at home. Okay, guys? All right. So let's go on with the lesson, guys. So we have the summary of curve sketching. And these are the guidelines, and there are checklists, right? And not everything here will be applicable. But why don't you go ahead and try to see if you could fill out as much of it as you can. Actually, how much of this do you remember? Okay, you should probably pause the video and try to fill it out and compare it to what I already have. Okay, all right, guys, pause the video. Okay, here it is. So in domain, you're looking for any restrictions. Denominator, square roots, actually nth root where the n is even, and things like that, right? So you need to be aware of any restrictions of the domain that's inherent to the function. And also, you have to sort of remember that x and y intercepts. By the way, just remember that intercept is not a coordinate. Definition of the x-intercept is the value of x such that y is equal to 0. And the definition of the y-intercept is value of the y-coordinate value, such that x equal to 0. However, when you graph it, you do need a coordinate. So that's why people might see it that way. But technically, when asked for x and y intercepts, you're just supposed to give a numerical value. Okay. And for the odd functions, we have definitions from the past over here, guys. And the periodic functions is p is a constant value. Like over the distance to the p, the function repeats itself in terms of the value. Okay. All right, and you gotta find out the asymptotes, the vertical asymptote, horizontal asymptote. You find that by find the limit as x goes to positive and negative infinity. L1 and L2 may be same, may be different. Sometimes, depends on the case. And we have a slant / oblique. That's the, I guess, official term. But in some classes, we only went as far as a slant asymptote. In some classes, went far beyond just slant, and we went to oblique, right? So you may have something that looks like this. These are the asymptotes, sorry. Asymptotes that look like this, and then graph may look like that, right? So that's a slant asymptote. But sometimes the asymptotes could take on a different shape. And it creates an envelope shape that you come across, right? That's why it's called sometimes oblique or envelope. Yeah, so we'll talk a little bit more about that later. And then, so basically the idea is that if you have a rational function, and n being the degree of the polynomial for the numerator versus m being the degree of the polynomial for the denominator, if the difference is 1, we have a slant asymptote. If it's greater than that, it's oblique asymptote or envelope asymptote, where you get something like that will be, because there's a line right there, right? So that'll be slant asymptote, but sometimes you may get something that looks like this, right? That's a difference of 2, okay? 2 in the degrees. And then we got intervals of increase and decrease, where the f prime is greater than 0 or less than 0. And then you got to figure out the local max and min. So if you go from negative slope to positive slope, the 0 in the middle, that'll be local min. For local max, you go positive then negative, and there's a 0 in between, that'll be the local max. I probably should have swapped the order, right? So the appropriate one goes below the correct word. And then for the absolute max and min, you find the c such that f prime is equal to 0, and then, or f of c does not exist, and then plug in compare all the values of fc, they could be more than 1, right? And the value, f value of the endpoints, and then you find the largest for the absolute max and the lowest for the absolute min over that particular interval. All right, concavity up is when f double prime is positive, concavity down is negative. And point of inflection is when, the way to find that is, first what you do is f double prime is equal to 0 or does not exist, and you're looking for sign change. Sign has to change. If it does not change, then it's not an inflection over the x value. Okay, sounds good. And then we end up sketching. So here is what we're gonna graph. Okay, so I'm sorry. I believe I wrote that as a limit here. My mistake. Uh, do what you can, guys. The first thing you should do is probably something like over here, guys. Stuff that we learned in pre-calculus class, right? A, B, C, D, and then anything that involves increase, decrease, local max and min, that's the calculus portion, right? So do me a huge favor and see what you could do over here. All right. All right. Pause the video, guys. Okay, the phase one of the graph is this, right? So we have this thing going on. So we found the domain. So domain could be anything except the denominator cannot be -1. That looks like a vertical asymptote. Yes, it is right there. And then x-intercept is when y equal to 0. That's when x equal to 1. And then basically that will tell you that it is what? 1 comma 0, right? It's pretty straightforward, right? And the y-intercept is when x equal to 0, the y is -1, so that would be 0, -1. Symmetry, I put in f of -1. That's neither equal to f of x nor negative f of x. So this is neither even nor odd. It's okay. So if there's a symmetry, great. If not, we move on. And horizontal asymptote, and when x goes to infinity and negative infinity, it turns out they're both 1. So I know that my horizontal asymptote is 1. There's one thing here that I didn't do, which you probably should do actually. It's a good idea that you do this, okay? And you draw a line straight over here, guys. Probably put f, value of the f. We know that it's 0 when it is 1, right? When it's -1, is undefined. So we know that the graph looks something like this. That right there is the vertical asymptote. And the horizontal asymptote, we know it's here, right? And knowing that, right, what can I do, right? Even before I get any values at this point, one of the things you could do is just plug in the values that we know. X-intercept is 1 over here, and the y-intercept is -1, which is here. And that's all we know so far, right? And let's come back to this over here, the y value. Let's plug in anything bigger than 1. What do I get? If you said positive, you are probably right, okay? And then you get negative here and you get positive over here. So we know that we have a shape somewhere over here and over here. And chances are we're not going to go below this line. And sometimes it's possible that you do this, but we'll figure that out by looking at the concavity, right? Or at least if you do this, the slope has to be negative here, right? Right. So my sense that it's going to be like this, and maybe, well, I don't know, it's in this region, but because it's negative, it looks like it's here. So my sense is that it goes up, and maybe it goes down this way. I'm not sure. Okay, let's figure that out together. Right, but my sense is that you usually goes this way and with some sort of curve or something like that, right? So we can sort of begin to figure out what's going on here already. Yeah. All right, guys. You know what? Maybe I should change that color, that to, oh, yeah, I don't know, that color right there. Okay. So have you done E through F? Okay, here it goes. Hold on, guys. Let me just erase this part that I had done previously. Okay. And then paste that in. There you go. And then let's talk about the stuff. That's the calculus portion. I took the derivative over here and then simplify to this point, right? So we know that f prime is equal to 0 and x equal to 0. F prime is undefined when x equal to -1, okay? So it increases from negative, wait a minute, it increases everywhere. Yeah, so what that tells me is that when you come here, oopsie, that was a mistake. I probably should have, yeah, that's what it is, right? What that means is that everything's just moving up like this. So chances are it's not going to come down and up like this, right? So it's moving up and it's moving up like this. And it may move around like this or something like that, but we need to know the concavity in order to do that, right? And then we have, so function does not decrease, nor there's no extrema, right? Because it's a 0 here, but sign did not change at all, right? So it's up, went 0 for a while, it went up again. And chances are when it does that, it probably does this, right? So the concavity would be negative followed by positive, right? Does that make sense? Right. And then it may just does that and go back like this. Okay? It depends on what the shape is. And then you do the double derivative, and that simplifies to after doing the quotient rule, right? And you go through your math, and it simplifies to this. And f double prime is equal to 0 when x equal to 0 or 1 over cube root of 2. I believe, if I'm not mistaken, that's like 0.6 or 0.7 or something like that, right? All right, and f double prime is dne when x is negative 1. Okay, so we got that does not exist, and it's a 0 here and here. When I plugged in the values, guys, to the sign analysis, it became positive, negative, positive, negative. So if it's increasing and it's positive, it's probably this shape. And we know that it's all moving, so it's either this shape or this shape, right? Because it's negative is like this, and like this again. Right? Do you see that? Okay. And the point of inflection is over here. We're going to put that all together and graph it. Now, one of the things you could do over here is that I already drew the number line for f. Oops, my bad. That should just be derivative, okay? So one of the things you could do is put all three of them like this if you want to help you work through all that, right? So that'll be negative 1. So they all should match like this. And then we got the zeros, y equal to 0 here and here. And it's a tight space, right? But you could sort of tell right now that because this is everything is positive, it's moving this way, and because it's positive and positive, it's shaped like this. So from to the left of the negative 1, right? So my sense is that this thing will be kind of like this, right? This is a rough sketch, by the way. Okay, and now because from what is this? A negative 1 to 0 is negative. It's looks like this. So my sense is that it's going to look something like this. And then up to this point, I believe that's 0.6. If I zoom in, there's a value here somewhere. I think goes like here, right? Yeah, that's what that was, wasn't it? Yes, it was. So it's positive, right? And my slope was 0 here and here. So, okay. So got it. So my slope is 0 here and here. So it went like this. And hold on. F prime. And then what we have here is, did I get this right? I might be missing something here. F prime is equal to 0. Oh, I think made a boo-boo here. Right. I made a boo-boo here. This should be negative 1 and 0. Okay, hence the confusion. Got it. So yeah, so at 0, yeah, that's right. So now it makes more sense, okay? Because you couldn't have 0 here, the slope equal to 0. So what that tells me is that it's kind of does that. It goes up this way, and then slope changed, the concavity. So it probably looks something like this, right? And then from what I could tell, it looks like that. Okay. All right, guys. So that's what that was, right? So sometimes this sounds like a good idea, right? But sometimes the spaces are so tight that it's not that feasible. So it's better to have this information and put it together as you do that. All right, guys? All right. So what I'm going to do now is give you the picture that that I got from what do you call that thing? Desmos, and here it is. Yep, that's pretty much what I drew, right? Except that should be a little tighter. So you can plug in a couple points to see where that is, but generally that's the picture that I drew, right? Okay, guys. All right. So here it is. Exercise B. Sketch the graph of f of x equal to x times ln of x. Why don't you guys go ahead and do this, and I'll go through the completed graph with you when you're done. Go ahead and pause the video. Okay, guys, we're back. So here's my work. That's it. That's all the work there is. And looking at this, the domain is all real numbers. That x is greater than 0. Put it together. Intersection of it is this. I found the x-intercept is, what was that again? 0. Yeah, 0, 1, right? And then y-intercept doesn't exist. Y doesn't exist because x cannot be 0 because of my domain. True. So as soon as I did that, what I did was I graphed 0 and 1. I mean, it would have been 0, right? But because of my domain, it goes this way. Okay. All right. What else is here? And the symmetry is neither even nor odd, so you could see that it's kind of obvious. So right there, I got no vertical asymptotes, and as x goes to infinity, it goes to infinity. So we know it just goes up. I don't know whether it's curved or down, but that's what it's gonna do. Okay, and the way we figure that out, and then we take the f prime, and that gives you f prime equal to 1 plus ln of x. When you solve for that equal to 0, x has to be 1 over e, or it's 0.368. Right? So, and then I draw a number line for the f, the slope over here, guys. It goes to negative and then positive and a 0. So clearly that's the local minimum. And when you plug that value into the original function right there, that gives you 1 over that. So that, I believe that point, yeah, I drew it so that that's 1. 1, 2, 3, 4, 1. That's 1, 1 right there, guys, right? So that's a half, that's a quarter between those two values. Yeah, so that is about 0.3678, 368. All right, and then we know that the function decreases from, it says negative infinity, my bad. It should be from 0, right? From 0 to 1 over e. And then f increases from 1 over e to the positive infinity. And then when I took the derivative of this, I got 1 over x, which means that's concave up for 0 to infinity, which means that it's a U shape. It makes perfect sense. I'm going to draw some sort of U shape and find the local min right there. And then there's x-intercept here. What might have been x-intercept is here. And it goes something like this. Okie dokie. Now, how do I know that's the case, really? Is there a way we can show this? Okay, let's try that, okay? So one of the things that we could do is that as x approaches 0, it's approaching 0, and that's approaching negative infinity. What's another way to write that? We could write that as x over 1 over ln of x, because this goes to infinity, right? This is going to 0. Another way to have written that is, in fact, ln of x over 1 over x, isn't it? Because x goes to 0, that's going to infinity. So that gives you infinity over infinity, doesn't it? So that's the L'Hopital's rule, right? So we could take the derivative of this. So what is the limit as x approaches 0? So that's going to give you, because it's 0, infinity over infinity case, right? So we apply the L'Hopital's rule, which limit will give you towards 0 from the positive side, sorry. That will give you 1 over x, and that's right there is going to be what? Negative 1 over x squared, okay? When you rewrite that, what do you end up with? That's simply negative x, isn't it? So that's telling me that I'm approaching 0 because it's negative value from the negative side. Right, so that's right. It makes sense, right? So it's approaching 0 from the negative side, from bottom up. So that's how I knew that knowing this, guys, tells me that my value was approaching 0. Okay. Yeah. So that's an additional thing that we all could do to make sure that my graph have a high confidence that my graph is correct. All right, guys. And here is example C. This is for you to do. I believe we've seen this before, right? Right. But just go through all the exercises and add the extra thing that I talked about with regard to this, which will yield F max and F min. And this graph has to go in between the two, bouncing up and down. Got it? All right. It asks you to graph that. I'm not sure if I went all the way to 2 pi. I think I barely did. So we're going to go over this in class and make sure you get it done, guys. All right. And we'll discuss it thoroughly during class. All right, guys. Thanks for hanging out, and I'll see you in the class or the next video. Okay. All right, guys. Bye-bye.